I cannot teach anybody anything. I can only make them think. Socrates. Honorable chairs, distinguished guests, and fellow researchers. Assalamu alaikum. Meaning that peace be upon you. This is Mahabubul Haq Bhuyan, and today I will be presenting our paper entitled Evaluating QBL Question Based Learning, a question based approach to teach programming at tertiary level of education. Co-authors for this paper are Saif Muhammad and Professor Yusuf Mahabubul Islam. Now let's talk about the table of contents for this presentation. I will start talking about introduction of this paper and move to existing gaps in programming teaching domain. Then I will briefly introduce our QBL model and how it can address the existing gaps found from literature. Then the methodology section of this research will be discussed. Later on, the main part, which is results and analysis of our QBL model, will be shown. As this paper is about evaluating the QBL model, I will suggest everyone to give special attention there. Then we can discuss about what science says regarding asking questions and its effect on brain, theory of constructivism, and lastly, linking all of it with our QBL model. Then the used references throughout the presentation will be shown. As we have already mentioned one of the great quotes from Socrates, let us see what science says regarding asking questions. According to science, the most effective way of thinking is by asking questions. When a question is asked, human brain becomes fully captivated and starts looking for answers. Our QBL model starts with a subject related curiosity question, and eventually during the programming class, more questions are asked alongside explaining theories and practical knowledge by the facilitator to consolidate learning. I will talk about QBL model in details in a later slide. The main motivation of this research was to improvise programming teaching and learning at the tertiary level. In order to find the current gaps in programming teaching, we went through literature and it says that the traditional teaching methods of programming have many issues. Educators' role in teaching programming, particularly teaching by static materials, focusing on syntax of the code more than developing problem solving mindset, and often using inappropriate teaching pedagogy affects overall learning of programming. A paper particularly discusses about the lack of guidance from the instructor negatively influences students' interest in programming classes. Also, having problems in basic design of the program lead to more errors and show poor performance in class. Now, let's discuss how QBL works. As we can see from the diagram, QBL starts with a engaging or curiosity question. Usually, it is a programming related curiosity question for a programming course. After the question is asked, students work in pairs and discuss to guess answers. Then the teacher looks into the answers and gives feedback to the students. After that, the instructor shows the appropriate answers alongside sharing experiences and theories. Thus, the teacher concludes about the question and moves to the next topic. If there is more questions necessary for the topic, the teacher follows the exact same process. In this way, the students never get bored and the class remains engaging. For the next topic, the same process is applied. For more effective learning, after the class ends, an assignment is given to the class which needs to be submitted before the next class starts. The teacher also needs to make sure to grade all the assignments and give feedback before the next class. Also, in the next class, the teacher first shows the common mistakes done in the assignment and then starts a new topic. In this way, the gaps mentioned in the previous slide gets automatically solved. If you have any further questions regarding how the previous gaps can be solved using the QBL method, you are feel free to ask me questions via email or online. As the purpose of this paper is to evaluate question-based learning (QBL), a course was designed using this pedagogy and being taught in a private university in Bangladesh. The course was named Introduction to Programming, and to evaluate the pedagogy, a survey questionnaire was prepared and circulated among students of different semesters who did the Introduction to Programming course. The survey questionnaire consisted of mostly close-ended MCQ questions and some open-ended questions. The questions were prepared in a way that the learning outcomes of the control group who were taught using conventional methods and experimental group who were taught using QBL can be analyzed and compared. Based on the results of a total of 300 respondents, graphs and charts were prepared to evaluate QBL and compare QBL with conventional teaching methods in the mentioned course. And now, the main part of the evaluation of our model, the results and analysis part. As shown in figure 2, it is clearly visible that more than 35% of the students in the experimental group strongly agree that the Introduction to Programming course helped them to understand the concepts of data structure course better, whereas it is only 30% of the control group. More than 30% of the experimental group agree that CSE 101 course was helpful for the next course, whereas less than 10% agrees the same for the control group. It is also clearly visible that the control group mostly disagrees with the given statement based on the percentage shown in three categories: neutral, not really, and disagree. This chart shows the retention rate of the students who were taught by QBL in the Introduction to Programming course, and it is way better than the students of the control group, which proves the long-term effectiveness of the QBL methodology. In figure 3, both the control group and the experimental group agrees with the opinion that launching a topic with a thinking question may help to start thinking. Launching a topic with a thinking question is the main foundation of QBL. However, as most of the respondents agree with the statement, it shows asking questions in class is important, which supports the necessity of practicing QBL in programming courses. According to figure 4, the confidence level of coding after doing Introduction to Programming course is evaluated. We can see that the control group's confidence level is low, where more than 10% are not confident at all and nearly 20% are somewhat confident. On the other hand, the experimental group shows a positive trend where their confidence level is much higher than the control group in three of the evaluation criteria: confident, very confident, and more confident than I expected, showing nearly 30%, 35%, and 27% respectively. This shows the success rate of the QBL method in the experimental group and the better retention rate for higher courses. As per figure 5, we continue to see the positive trend of the experimental group in terms of coding skills. The percentage of the experimental group is higher on decent, good, and very good criteria than the control group. Also, more than 15% respondents of the control group rated their coding skill as not good, whereas it is completely none for the experimental group. In this slide, we will see some responses only from the experimental group to further evaluate QBL method for programming teaching. According to figure 6, almost everyone, 99% of the respondents, recommends this teaching method for the next coding courses. Also, the experimental groups were asked whether the teaching methodology can be improved or not. In figure 7, more than 70% of the respondents said that this method is perfect, and almost 20% said that it can be little improved. However, the respondents didn't mention how to improve the method, which indicates that the method is already good enough for programming teaching at tertiary level. Research shows that human beings cannot multitask. Asking a question triggers a mental reflex called instinctive elaboration. When a question is asked, the human brain is captivated and it starts looking for answers. And when it's thinking about answers, it cannot think about anything else. According to the theory of constructivism, humans construct knowledge and meaning from their experiences. Students learn by fitting new information together with what they already know. By asking questions, we can further improve learning according to the theory of constructivism. As QBL method is all about asking questions sequentially, the answers given by the students confirm that they are at the correct place of the brain, and therefore new information is ready to be constructed or stored there. Question and theories explained in the class in QBL pedagogy facilitate the construction of new knowledge and therefore support the theory of constructivism and what science says regarding asking questions. Here are all the references used throughout the presentation. Thank you everyone for your time and patience. If you have any questions, feel free to reach me using the email provided. I wish you the overall success for the conference. Thank you once again. Assalamu alaikum.